discover the storage system, and the block operations, which are for managing the storage system. The discover functions populate the registry with the connection parameters, and then the block operations use those connection parameters or pass them to the Scale.io REST client factory to get a handle for the REST client, and then make requests to the Scale.io REST client. And after we implemented this, Shujin tried to deploy, and she's going to talk about some of the challenges that she faced with that process and the steps that she took.
So for now, we just use the manual deployment because the automated one. Okay, so like before we actually try the deployment, we will need a working CoprHD with the support for Southbound SDK, which means is the Southbound SDK UW branch. And then we need to build our job file, modify several configuration files in order to enable the new driver. Then remove the old RPM, rebuild the RPM, and copy the job file into the specific directory. Then add the job file name to the class path, and raise down the whole service. Actually, each step is problematic. I can't cross problems from like one by one from each steps. We will come back to this to talk about the problems for deployment and the related problems later in our discussion session. And I think it's demo time for Warren.
Thank you, Susan. So we mainly discover the devices using the CLI command.
So the interface uses CLI or is it REST API? So for the scale IO?
Yeah.
Are you guys using CLI based?
The REST API.
So
REST API, right?
UI for this haven't ready yet, so we need to use the CLI to
CLI.
support the discover using our driver.
Oh, this is the CoprHD scale.
Yeah.
Now I was talking about your driver implementation uses completely the REST API.
Yeah, REST API.
Interface
We use
for
REST
scale
API.
IO, right?
Yeah. So first I do the authentication to the scale device. Oh, it's okay. I don't.
So he's now authenticated with Viper CLI, CoprHD CLI, actually.
Every time someone says Viper, they have to put in $1.
But it says Viper. We need to change the
Does it
CLI.
become $10?
From the back end.
6 or 5?
Since I traverse both the worlds, I am not going to pay.
So you can put here and take out there. I like it.
By the way, live view looks great. I can see everything there, so that's just demo mode lights already.
So while that is going on, you guys can actually do a Q&A if there are questions.
Yeah. Do you have any questions? Also, one thing that I kind of skipped over was our current status. We have the discover functions implemented as well as the snapshot and clone.
Yeah, the pull request is ready there.
The volume provisioning is in progress, so that'll be done soon. And what we have left to do, we should complete in 3 to 4 weeks. And that includes what does that include? The export, right? And clone operations. Yeah. We expected, or we had anticipated, to be totally done with the driver today. But we had some unanticipated challenges with our schedule, so our expected completion date is now 3 to 4 weeks from now.
So how can we do snapshot if we don't do provisioning?
Oh, so I use the CLI to create some values in the CoprHD, then test with these values.
Oh, I see.
Yeah. And the second one is the second row which shows the P domain, which is actually discovered using our skill.io driver.
This is live?
Yes.
Yeah. So you can see the pools for that particular storage system.
So for the scale IO stuff, did you guys use the Vagrant images? Or,
Yeah, we use the Vagrant images
okay.
to create the skill.io devices.
Yeah. Thank you, Kurt.
You're welcome.
What is that?
So we have one pool over here, the pool one, which is in the skill.io device. And these are the ports that have been associated with that. We have 3 ports associated with the skill.io device. So that's pretty much it.
Are you creating the network and discovering the hosts and all of that stuff too?
Sorry?
So in the old Scale.io driver, when you discovered it, it would also automatically basically create the network, and it would kind of discover all the nodes as hosts. Is that also happening now, or
Yeah, you
are we
can
changing that model?
see the host.
So these are the scale IO hosts in the discovery?
Yes,
It's there.
Yeah.
it's there.
And I've always had misgivings about.
Yes, because this is
Ports, but
using the same background file, so the scale cluster is the same. It's just a different location. The pros and post results are the same.
Hosts will be required when we do the export.
Right.
So I don't think they've reached that stage yet, right?
Yeah.
No.
So when you do the export has to be detected by on the host side on some Linux machine, right? On that machine, you need the scale IO data client deployed.
SDC.
SDC has to be deployed. So
Right, so maybe there's a discussion here.
In the background
Outside the
images,
scope of drivers.
there's SDCs installed.
and it's
in each
outside
of-
the scope of the drive.
Maybe that this is an area we want to discuss further later on if there's a chance to improve it.
I think as an SDK, it doesn't make sense to add host discovery as part of the
Exactly.
Southbound SDK. That should be.
Right, that's what I'm thinking, and but the current approach is kind of weird
Yeah, that's a
with the way it does it.
Well, because the driver presently in the native model is not insulated in any way from Viper, a driver can do anything.
Right.
But when you have the driver that's behind the Southbound SDK, then there's a more deterministic set of operations that are supported. And so, think about that.
So what's the current flow with the host discovery? How does it happen?
So
Just a high
for
level.
everything else,
If you would have
host
SDK, Southbound SDK in the mix, how will it happen?
So here's the thing. So host discovery for every other case happens directly between CoprHD and the host, and that's it. But for Scale.io, because Scale.io has its own way of communicating with the host, right? There's a little driver that you have to put on the host in order for the host to be able to see the storage of Scale.io.
That's true.
It's like a client thing,
Yeah,
right?
that is true even with Ceph and
Sure.
cluster.
Yep.
May not, I don't know about the cluster.
So the way that it's happening today is CoprHD goes talk to Scale.io. Scale.io tells it about all of those hosts that are out there that can see it. And then CoprHD creates a host instance for each one of those. And it also creates a network, or what CoprHD understands as a network entry. And it puts supports for all of those hosts and for all of what it considers to be the storage ports on the Scale.io side.
Southbound SDK has to have host-related functions too.
If I don't, that's my question. So
What does it have?
that's where I think we need to talk about.
Our Southbound SDK, apart from dealing with storage, has to deal with hosts too. If there are protocols like Scale.io, Ceph, etc., which are slightly
It's not
not iSCSI or fiber channel
some
or
setup on the host.
Right.
Unless we expand on the host side to be able to discover that kind of stuff, right? So that you could then say, so I got these ports from the equivalent of ports from the array, and then on the host, when you do a discovery, I detect that this host has the client for Scale.io, and then say, oh, okay, so they connect to each other.
So how does it work in the current driver model? So you have a Scale.io instance.
Yeah.
You provision the volumes. Now you want to attach a volume, let's say, on one compute. For you to attach a volume, you need an SDC on that compute. Does Viper do that today?
No, Viper doesn't install the SDC. What he's saying is that the native Scale.io driver leverages the fact that Scale.io knows what all the hosts are that are attached to it. And so that driver, in addition to discovering Scale.io, creates host entries in Viper's database representing all the hosts that Scale.io talks to, and also creates the virtual array network entries that show this host can talk to this array.
And the reason is you already installed the SDC on set of compute nodes.
Right. The assumption is that the Scale.io and
Now
the
there
hosts
is
that are already.
there is an argument to say, well, maybe that's something that we should do. Maybe you should be able, because the problem is it introduces a scenario where you have to know outside of CoprHD that that host can see that scale IO in order to even go in and say, I want so much storage of this kind to that host.
Yeah.
Otherwise, it'll get a failure.
Exactly, but I'm with Anil, right? So it doesn't make sense to pull the host information from Scale IO. While it may work beautifully with the Scale IO instance, it's not going to work with Ceph.
Yes.
Ceph has no clue about the clients. You can basically install Ceph client runtime somewhere and start consuming them. It has no clue.
Exactly.
It doesn't keep track of it. I suspect it will be very similar with cluster too.
Yeah.
So
maybe this is an opportunity
yeah.
to think about it at least and decide if we want to make because like you said, it's work that's going to be used in the future for Ceph.
So who is capturing the ARs or minutes?
Huh?
Who is capturing the minutes?
Minutes. It's all on YouTube. We're talking about.
So you're going to listen and capture there again? Convert it into speech to text and then see and then automatically dish it out to the right
Anything
person.
to do with Southbound, one of you guys should note it up.
Let's start paying attention.
One thing I was thinking is instead of each scale IO or other storage device knowing about all possible clients, it's better to have a layer of indirection. The clients know some controller's address. The controllers know all the storage addresses or ports or whatever. So then you can always connect them to that.
I think the key thing is how do you know which ones are the compute nodes and whom do you tap into to figure out the compute node. So if it is OpenStack, most likely you can actually go to the Nova and pull all that information. If it is VMware, you can probably pull that information from vCenter. But the challenge is how do you parse it out and say some of them are not really compute, but rather just pure compute versus some of them are used by storage nodes, right? So, but in general, the goal is to figure out if you can tap into the existing repository and then build from there, as opposed to you launching a massive discovery to figure out on your own.
For fiber channel, things are easy.
Because you don't need anything on the client side, but because the emerging scale-out infrastructure.
Likewise, for iSCSI things are easy, but our NFS things are easy. But beyond these three protocols,
you need
we have proprietary protocols. Definitely, we need an ability for the driver developer to do something to get the end-to-end, provisioning working. And that could be a completely proprietary thing, which is like optional. If you are writing a driver for fiber channel array, you can leave those things as not required.
Okay. This may be a very stupid question, though. When you do export to a compute node, would it make sense to actually bootstrap some of the compute runtime for a given storage backend to work seamlessly?
No, why? I mean, in the majority of cases, that may not be required.
You're just talking about having the capacity. If you need a client installed on the host in order to connect, have Viper do it, or have CoprHD do it. And that's a valid question. I mean, like I said, in the case of fiber channel type stuff, you don't have to, but in some of these other ones that we're moving toward, you might. And
because the exporting is essentially bootstrapping end-to-end and making sure that the whole connection works.
True.
That includes the runtime software exists and set up.
Yeah.
As opposed to assuming that there is a package and there's just configured.
Because the problem is if you don't do it, the fail states are ugly. You all of a sudden start trying to export the device to a host, and it's just you can't really get to it, and you start getting weird errors,
and you don't want that.
Right. So I put it in the parking lot, and then any ARs would come out after we talk. That's another thing I forgot to mention earlier. Usually, we just start writing whatever comes up.
Not as part of Scale-up, as part of Southbound.
Sure.
Okay.
So I'll fix that. That's fine.
Because that makes it more generic.
Yes.
And we don't want to cut into Evgeny's time too much, but there are a few things that we wanted to get your feedback on.
Okay.
They were things that were challenges for us, and thinking about future developers who might not have the connections and the support that we had. We thought we might bring them up as areas for improvement.
There are three major difficulties or challenges we are faced in these three stages. So we will discuss that.
Yeah. So during the design phase, while starting the project, it was kind of a bit difficult to understand the terminologies and such as the similar kind of protection domain ID, the native ID, everything is kind of similar. So understanding this kind of terminologies at the starting and the kind of architecture, it was kind of a bit difficult. So going forward, if kind of documentation, which should really help for the future developers to have kind of.
Question on that one though, with the existing wiki documentation, where do you see the gap? Just look at the current state of documentation that exists with wiki. Developer-centric documentation, not how to use CoprHD, but rather how CoprHD is built.
Like how to build the
architecture document.
If you were to look at the architecture document and the flows, all that stuff, for a new driver developer, where do you see the gap?
So maybe design was a bad word choice. It wasn't really the overall architecture that was confusing, it was the terminology. So something would be called
like something would be called protection domain in ScaleIO, it would be called system ID in somewhere else. So for like the most time we spend on this will be understand the whole thing. We read through the SDK specifications. There are terminologies and their descriptions, like not much description there. And to figure out what this thing map to which thing is hard for us. Because we don't know what it means for CoprHD as a device label, and what it means as a storage name when we come to ScaleIO.
Yeah, that's a very common problem. It's the secret sauce of storage, right? So what I've been thinking of is building a sort of visual dictionary where you have the concepts as CoprHD sees them, and then maybe a table underneath where you then say,
that would be huge.
on Vmax this means this, on VNX this means that, on ScaleIO it means this, something like that, and then sort of like cross-referencing back and forth, full of hyperlinks everywhere.
Yeah,
that will be even just as confused, but at least it's documented.
Yeah, that would be really helpful because.
So that, that's a good point. We need that.
Okay, give an example. I'm still struggling. When you say the storage uses certain terminology, because see the thing is, here is my view. Somewhere you need to have some common terms and verbs that you can actually latch onto to develop all the drivers. So there is always that challenge of mapping what it means to the driver versus what it means in the Southbound SDK interface layer. But
so like we have a couple of models in SDK. We got storage system, storage ports, like for each specific stuff.
Okay.
And
systems, pools, and ports.
Yes, like this is an example. Then we need to like use the REST client to get the information we need from the ScaleIO. And somehow we need to assign this value, this data into or populate all these modules, right? Okay. And we got all those stuff. Which one we should point to here? So there's storage name and device name. It's all about name. Which one goes to which? Well,
so what I'm hearing is, one thing is you need to know, or the documentation of the SDK needs to very clearly define each field of the data model. What is it supposed to represent? And that, if there's not enough documentation there, then that's a great area for you as basically sort of the beta testers of the SDK interface to comment and say, okay, these are the areas we were confused. Either point out what needs more documentation, or you can submit.
Then I can help you. I can help you find the answer. But
that totally makes sense. That totally makes sense. But if I am the storage system guy, I should know what exactly I mean by a storage. So if you are writing a ScaleIO driver, you are not expected to write a ScaleIO driver without knowing the ScaleIO internals. By nature, you are expected to know what ScaleIO driver does, how you can actually use it programmatically and consume it. But when it comes to bridging that gap with the Southbound SDK, you need to figure out what exactly pool means in Southbound SDK so that you can take the pool in ScaleIO and map it to the right construct in the Southbound SDK. So the documentation has to be there in the Southbound SDK.
But then
Yes.
ultimately, there's a step of
But there is a
understanding the
bridge.
domain enough of your driver to map it onto the
Exactly.
SDK.
And
That's
then
where-
when you
that's
do it,
where-
you map it and kind of make sure that is documented for.
That's where showing examples helps, because then people can be like, oh, that's this thing over here.
Yeah. Another example will be in the protection
Protection
domain, because it will be the system ID for the storage system. That, because this name is totally different. Yeah. If you don't have a clear definition of this, we don't know this. Because in SCAI, we also have a system ID. Why not this system ID being a system ID in the SDK?
Yeah. So it sounds like there is a need for more clarity and
More information.
descriptions around the Southbound SDK terms and taxonomy.
There's a need for a general taxonomy, period. I mean, I think a storage taxonomy would be extremely helpful to a lot of people outside of the context of this room. And if we did that, marketing guy, I think of clicks and SEO and people coming in, but, disregard that. But regarding this, I think it would be extremely helpful.
Do you want to talk about deployment? Or the
Yeah. Implementation.
Talk about the implementation. Okay, we had some challenges with the setup too, and one of the suggestions we had was maybe some kind of template that would define the file structure for a driver and include some of the utilities that we used and some of the base classes that were provided to us. If we wouldn't have had the connections and the support, we would have been writing those on our own. So it would be good for those to be consistent between drivers from the Copperhead perspective, and then from the developer perspective, I don't want to be writing code that already exists.
So having a visibility into the existing sample driver somewhere, is that what?
So
we need to
that
be
basically
addressing,
means
or-
for us, we don't really need to write the SCAI REST client because it's already supported. It's already finished by EMC. We just take their module. But for another third-party developer, they need to have their own REST client. They need to have their own factory. So if they need to write this from scratch, there will be a lot of work. But EMC already have the base REST client ready, have the error handling ready, and have some service utils. So if they can provide this code to the developers, it will be hands-on, will be easier.
So it was not provided to you guys, or what's the problem?
We have been provided
It was
for the
provided.
future developers.
It was there? Okay.
Yeah.
Okay, now step back and look at a different storage backend. Let's say I'm going to write it for cluster.
Yes.
Write a driver for cluster.
So
or
if it's
SolidFire. What is needed?
So first, we don't need each driver has their own error handling. We don't need each driver have their own based REST client. And we don't need, they all have their own, some service utils. It's all common thing we're all gonna use. In the first functionality gonna be the same. We don't need to write it from scratch.
That's true though, but okay, I'm
But
trying
this
to
will
parse
be
it to figure
something-
out what needs to be done
So
for the new development. That's the reason why I'm asking these questions. So let's say if you're writing a driver for the new backend, storage backend, and you have a REST-based API interface, you could have potentially guidelines saying that, hey, if you have a REST-based backend, and here is how you write a driver interface. That's one model. If you say you don't have the REST-based interface, you have a command line. Here is how you actually write an integration layer for the command line based storage backend.
Yes.
Yeah.
That will definitely help for new developers coming on board for the new backends that may not have everything in REST-based and that may not have all the bells and whistles associated with exception handling, recovery, and all that stuff. Is that what you guys are recommending, or am I off?
Yeah, that's what we were thinking.
It's kind of template where all the base
based
functionality
on
is there.
different approach.
Okay.
If you have a REST client, you can have the basic REST client modules ready, and he only need to implement the specific functionalities, not base stuff. And if you use CRI, we can have the CRI basic stuff ready. So it will be just lower the time.
Yes.
Yeah, and complexity.
Yeah, the implementation time would be much faster.
Right. Good point. Yeah.
You want to talk about the deployment?
Okay. So I actually start deployment from last week. So there's not much time for me. So we don't have the integration test ready. So as I said earlier, each manual steps are problematic. When I finally solve all the problems and get to the point that I can test the discovered system, I'm so excited to open the user interface. Okay, there is a storage system there, and I click on the pause and pause. There's nothing so up. So all I can do is just go back to the controller service log and read from the thousands, like millions log, lots of log. And the only thing says there is like, first, you start discover pause. No pause returned, nothing else. And we don't have the test there. We don't have effective debugging tools. All I can do is just go back to the code, add like a log, extra log. Then do the review the job, redeploy the driver, discover again, read the log.
Yeah.
Again and again until I found the problem.
Yeah, it was kind of a tedious task because you need to insert some comments in the code line and you need to go on through the log file again and again till where the integration test has come up. So it was kind of a bit difficult during the deployment time.
So
the problems were actually the driver code, scalable driver
the
code, or is the above?
problem is how to test the driver when our driver is ready. Is there like, what's the more effective way to do this? Do we merge our driver into Aragonese branch, then like someone write the integration test to test, or there's other way? So now we don't have a way to test. So what I did there is I deploy and perform the functionality and read the log. It's really not fun.
I mean, we may need a test harness that just engages right at the SDK level to where you can test one of these drivers without everything else.
Yeah.
I mean, obviously some of it's needed, but I don't know, that's a good.
Yeah.
What is the good way here?
Probably we need kind of we can cover some of this here, but probably we need sort of a post-mortem on driver development that we can get Evgeny and you guys and some of the rest of us in a room together and say, okay, how can we make the second driver easier than the first one was, and what new infrastructure needs to be built, what new documentation needs to be written, kind of go through all these steps. So
I think it will be good to pull in the Ceph, whoever is writing in Randy Biasti, pull in and get some pulse on what their experience is, and then maybe compare and contrast and see what we can do better.
I'm not sure they're using this. I know they've talked to Evgeny about Southbound Driver. I don't know if they actually use that.
I thought they're not using the Southbound SDK, they're using the other one.
Yeah.
Right?
Yes.
Because it's not even ready, they can't, so they're complete.
Right.
So, okay, so that's what I thought, but I think Kurt, you were saying, they're probably using the Southbound.
Yeah. I know they've talked to Evgeny about implementing through the Southbound SDK, but they didn't. It wasn't ready for full implementation, so they just went ahead and did it, and then I guess they'll.
They wrote a native driver.
What's that?
They wrote a native driver, is it?
Yeah. And if you search, in fact, if you search on GitHub, you can find Ceph driver for CoprHD.
I will look it up. I haven't done a good job of looking it up.
Or so I was told. I haven't looked for it myself, but I was told that they have their own fork. So basically, they have a whole fork of CoprHD in GitHub where they did the driver development.
Okay.
We'll cross our fingers and hope that it merges in cleanly when they decide to.
But, so, I think ideally, this has been a pretty much a painful process in Cinder community as well, right? You write a Cinder driver, and the question is your driver working correctly or not? Is it really working the way it is supposed to be? Then the second aspect is, okay, is your driver introducing some other side effects? What would that be? So this whole CI, and then when someone is writing the framework changes, whether the drivers that you wrote are already working or not. So there is a need for CI test framework. I know we talked in the last meetup. We haven't done a whole lot of that, but a portion of that CI framework was to look at the OpenStack side of the world too, right? Because, sure, you guys will probably talk about that tomorrow. But in general, it's just not the driver testing, but just the CI. And then how does the driver pull request will be part of that CI scope.
Yeah, so those were some of the suggestions we had and challenges we faced. I think it's about everybody's time to talk about the Southbound SDK. So thank you for your feedback.
Yeah, one more. We have a pull request for scale story and operations. So please, please agree.
We're all going to be around there.
Yeah.
Okay. I have some ideas that maybe might help the debug process.
Okay, thank you.
So 3 weeks, you'll have pretty much everything done on the Scale.io, right?
Yeah, we covered.
Is that?
Maybe I mentioned that. 3 to 4 weeks, we'll be done with the Scale.io driver.
So would that mean the Southbound SDK framework will be ready, Scale.io will be ready, and we can comfortably say that it is something that works with the new Southbound SDK with one driver? Is that after 3 weeks, both SDK as well as the Scale.io driver fully
I can only say about driver.
Right
so the
now,
SDK is just everything, right?
Okay, so you will have the driver implementation ready. You will do some amount of testing based on command line or through the standard Southbound SDK interfaces if it is feasible and ready, but the Scale.io driver will be done.
Yeah.
Right. What I'm hearing from their presentation is we've still got some work to do on integrating drivers that are written against that SDK. What I'm hearing from Susie is there's a whole bunch of magic you have to do manually to actually integrate one of these drivers once you've written it, right?
Yes.
And then we also.
So I think someone, I don't know who, should be working on like automatic the deployment. Now it's a manual.
Right, plug-in style adding of a driver as opposed to going in and tinkering with the build. And then the other thing that we don't have in the Southbound SDK right now is scope extending all the way up into the UI, which they kind of hinted at. Right now, the UI knows explicitly about all the different types of storage systems that can be added, and it doesn't have any way to interrogate and say, hey, has a new driver been added? And if so, what kinds of questions do I need to ask about it? And so to get this one actually working, some work that needs to be done in the UI to recognize a SDK-based Scale.io driver and get it where you can do discovery through the UI and the rest. And so I think there's some moving parts that I'm not sure have anyone actively working on them at the moment. Yeah.
So now, maybe this is completely orthogonal question that if you were to look at the Scale.io driver, how many lines of code is it compared to the existing Scale.io driver?
It's comparatively less. But the
50% less, 25% less.
Really.
Just
probably 50% less. For
that's
the
substantial. That's 50%.
Yeah, because for the discovery functions for storage systems, pools, and ports, it's probably around 250, lesser than that.
Lines?
Yeah. Means compared to the previous one, it's around some 75 to 100 lines. It's pretty less than that.
Okay.
I want to say though that let's get provisioning working and then snapshot. But we are not doing provisioning.
All right, thank you. My name is Evgeny Roitman, and I work on Southbound SDK for CoprHD. So I primarily drive all work, starting from architecture, design, and I'm doing implementation. So we started this project in September after the first meetup. So in September, I presented a design proposal for the SDK, and first draft of the interface definitions, object model definitions have been presented. Now it's easier for me to do this presentation because we already have working stuff. So we already have SDK partially implemented. We have first Scale.io driver, which is built on the SDK, and it's much easier to talk when you have something working now. So primary goal of SDK was to kind of decouple concerns. Instead of developers understanding all kind of idiosyncrasies of how Copperhead should work with database, with coordination infrastructure, Zookeeper, with like how it should complete internal tasks. We want to separate this and make it only concern of SDK implementation, and then driver should just take SDK, implement required interfaces. Object model is provided as part of the SDK, so driver should work with this object model, just do translation between object model of SDK to object model of its storage array. And that's all. So all complexity for the driver developer is focused on the understanding physical storage, understanding how to talk to physical storage, and just implement required interfaces. And then testing, it should be simple, because for testing you don't need to deploy Copperhead. You just deploy, you build your driver, compile jar, implement simple test client, and test how driver works. And after that we plan to have simple automated installation, deployment of drivers into Copperhead, and then maybe do some integration, final integration testing. And it goes well. We have kind of plans for Yoda to release core functionality in SDK. So we release discovery and block provisioning support. Essentially, it includes array pool sports discovery. That's part of discovery. For block provisioning, we support volume operations, create, expand, delete volumes, volume export operations, create export, update export, delete, consistency group operations like create volume inconsistency group, snapshot consistency group, etc. And local protection operations, snap, clone, mirror, which are applicable either to individual volumes or to consistency groups. So this is planned for Yoda release, and it's targeted for April. Okay. So other task for us is to automate driver installation into Copperhead. Currently, we have manual way to install driver. So it's basically like developer needs to know to modify couple XML files to add the driver kind of fully qualified driver class name mapped to storage system type, and then restart Copperhead services to complete driver installation. And that's what we plan for Yoda. For after that, for post Yoda, we are thinking and we plan to have UI-based driver installation into Copperhead. So that means that Copperhead UI will have special service catalog, which will ask several questions about driver, primarily what is, say, driver location, driver jar file location, what is storage system type, and then if it's kind of provider-based or system-based driver, and essentially that's all. And after that, this process will run and it will install it will copy driver jar to specified location for Copperhead to upload its classes, and then and modify several XML files to consume this driver. And our target is to do it in kind of persistent way, so driver installation should survive Copperhead cluster reboot. That means after we install driver, so we install driver and then for some reason we reboot Copperhead cluster, driver installation should remain live. So developers shouldn't go and reinstall it again. I have only like 5 slides, so I go over all of them and then we can discuss. Also, next step after Yoda, we plan to introduce a comprehensive storage capability model into SDK. So this will focus on how to discover and how to use default and custom vendor capabilities on CoprHD. Essentially, default capabilities, it's kind of common capabilities which have well-defined semantics in storage management, and CoprHD provisioning stack integrates default capabilities into internal constructs. So that means CoprHD understands what this capability means and knows how to work with this up to semantics level. But specific vendors may have specific unique capabilities for their storage systems, and for this we plan to support this kind of set of custom capabilities, which essentially are opaque for CoprHD. So CoprHD not necessarily understand what they mean, but it can discover these capabilities, discover their types, and then when it discovers storage system and pools and ports, it also can discover capability instances of storage elements for these custom kind of capability definitions, and then process them, show them in user interface for, say, vpool definition, and then use selected values for these capabilities for vpools and match to right set of storage resources like storage pools and storage ports. So that's essentially pass-through treatment of custom capabilities. So they're opaque, but we can consume them, we can show them to user, we can do some placement based on these capabilities, but essentially we don't understand exactly what they mean. So that's also targeted post-Yoda release. And this slide presents a roadmap for SDK. So we currently in phase 1, which is API for block discovery and basic block provisioning operations.
And we're still seeing the first slide. Are we supposed to be seeing some following slide?
Yes. You don't see. What slide do you see?
Release is what we're seeing.
Yeah, we're on slide 1.
Slide 1. Or let me do this. I don't know why it happened.
We're not seeing presentation mode. We're seeing the normal loading.
Ah, well, I understand. Because I moved in presentation mode. You know, I will then use this normal mode. Can you see second slide now?
No, third.
Now 3.
3, all right, okay. So this is number 2. Driver installation into CoprHD.
Okay, and you talked through that one already.
Yes, I already talked about that. Yes, it's like manual driver installed, that what we have now, and that post Yoda we plan to have UI-based driver installation into CoprHD, and the goal is to have persistent way to install this driver so it survives CoprHD cluster reboots. And And I also talked about this. This is number 3. Can you see it?
Yes. So Evgeny, can you go back to slide 2?
Yes, I'm on slide 2 now.
Install the second bullet. What do you mean by that?
So what I mean by that, the driver artifact is jar file. So whatever driver uses inside jar file. So now this jar file should be deployed into CoprHD. So there way to do it through user interface. There should be way to do it through user interface. So let's say CoprHD is running. I go to user interface. I open service catalog screen, install third-party driver, specify driver jar name, location, storage system type, and execute installation. That's what it does.
So from the UI, will it be a REST API, or how will it? So this is the.
Yes, it probably will be REST API supported by CoprHD for driver installation.
Okay, got it. I just wanted to make sure it is REST API and you can run it from command line and UI.
No, yeah, it should be API, REST API. And yeah, once again, this is not in Yoda, it's post Yoda.
Yeah. For Yoda, at least the ScaleIO driver should be there by default, right?
Yes, we plan to have it by default. Yes, there's only one currently hard-coded place in portal service which we need to add ScaleIO driver. All other places, they are XML files, so a couple XML files which we put as part of the Yoda release.
So one question, Evgeny, on you mentioned with UI, you said it's the catalog services that will integrate with the driver installation and configuration. But essentially, the UI has 2 components. There's the catalog services, and then there is the element management part. So shouldn't this be more like a system management function as opposed to catalog service function?
Yes, system. Yeah, because for me, I wasn't aware about this kind of separation. But right, it's system management. It's not. It belongs to system management. Yeah.
Okay.
Okay, so slide number 3, storage capability model support. This is a big task which I started to work long time ago. I made a couple kind of design documents, and it's complex task, especially for like custom capabilities. So idea here is to have 2 types of capabilities. First type is default capabilities. So that's what we already have in CoprHD. We have kind of capabilities which are integrated into CoprHD, and for most cases, many vendors support them. And CoprHD internally knows how to work with them, what they mean, and how they do placement based on these capabilities for storage resources, for storage volumes, file systems. Other type of capabilities which also we will need to process if we want to work with third-party arrays are custom capabilities. So that's capabilities which are not common to some arrays, but unique for some specific array. And for these capabilities, we want to consume them, discover, consume, enable selection of storage resources based on these capabilities, placement of storage resources based on these capabilities. But we cannot like semantically understand them because they're unique for third-party array, and we don't have internal implementation. We plan to have like pass-through, discovery, a representation of these capabilities and then using them in provisioning based on some like predefined rules which come with capability metadata, which we discover when we install driver.
So question, Evgeny, on the custom capabilities, what would you do with it? How would you do with it? So for example, you go and discover SolidFire, and it basically gives you QoS, 3 different types of QoS settings, high, medium, and low. What do you do?
Okay, so SolidFire. So what we do, we will discover them. So for each storage pool or whatever these capabilities map to, when we discover this construct, we discover it with capabilities. So we store them, and we know that this is capability name and this is capability value, for example, like quality of service gold. And then on the UI, when user creates virtual pool and specify that I want a storage type SolidFire, then we will show quality of service as one of the parameters of available capability for SolidFire. And then based on the discovered storage pools, what quality of service they have, we will show that there is gold, silver, bronze, for example. And then user selects, I want a quality of service gold. So that goes with a virtual pool definition. When user goes and provision volume for this virtual pool, then we specify in request to the driver that this volume should be provisioned with capability quality of service, which has value gold. And then driver understands semantics. We don't. We just know this is capability name which is required and this is capability value. So that's essentially what we plan to do. We plan to discover capability, custom capability, present them to user when user builds virtual pool, and then use them in provisioning to match resources which support these capabilities, and then send it back down to driver, so driver really place this resource on the right, say, storage pool.
So Evgeny, there will be a custom capability storage pool matcher, something like that?
Yeah, storage pools and storage ports, maybe some on the storage system level.
Okay.
Yeah. Yes. Yeah. Each discovery request in driver, even now in the driver SDK in the interface for discovery storage system has parameter for capabilities. Discover storage pools has parameter for capabilities, and the same for storage ports. So when we discover, driver can specify set of capabilities which are name value pairs, name mapped to different values, for example, set of values. So we can discover them. Right now we don't support them, so we say we said to scale your driver, just don't discover them. Put now. But as soon as we support them in SDK, we can say just use them. Whatever capabilities you have, put them in this parameter, and we will process them, and we will show them for user selection when vpool is created, and we use them for provisioning. Any questions on this slide?
I think we're good.
All right, so slide number 4, Southbound API roadmap. This is a slide from September presentation. there's no change here, but the only difference is that now we are in the phase 1, in actively working on phase 1. SDK already supports block discovery for arrays, pools, and ports. SDK already supports volume operations, volume create, delete, snapshot operations, consistency group operations. And I currently working on expert support in SDK, and then I plan to work on clone and mirror support. So that's the plan, and it should complete phase 1 close to April. And so, and yes.
Okay.
Question? There was question?
Yeah, I said, is export support going to be in Yoda?
Yes, it will be in Yoda.
So you said you plan to complete it around April? Is that what you said?
Yes, close. Yeah, in Yoda, for Yoda, it will be completed around April all together. Phase 1. Yeah.
I don't think we'll probably be accepting new code into Yoda by April, so we need to converge on that. But
okay, we will work on this. Then we will need to cut maybe mirrors could go after Yoda. But experts will be there. Expert support will be there before April, which is important. And after Yoda, we plan to work on phase 2 for SDK. It's API for file discovery and provisioning. We need to go over to see if we have any obstacles to support Vplex orchestration for third-party arrays, and also we need to support metering and monitoring APIs. So this is phase 2, and it targeted after Yoda. And then phase 3, this is enabling of orchestrations, third-party specific orchestrations for data protection and high availability. It's not clear when we start working on this, but this is on a roadmap. Okay, slide number 4. I put some maybe candidates for open questions and community projects. So, as I said, driver it's not dependent on Copperhead. The only dependency is it should kind of have SDK jar on class path and implement interfaces and use object model inside SDK. So not clear why we need, how we, like, when people start develop drivers, should we have separate Git repository for southbound drivers, or they go to this common Copperhead repository? That's what I think we need to decide at some point.
I know when you were trying to separate the Copperhead into logically into a few Git repos, I don't remember exactly what was decided. I know we said, okay, it makes sense, and then you had a proposal, and
right, we
did
have.
that fall under that scope at all?
Can you, Evgeny, can you hear everybody's question?
No, sorry, I couldn't hear it.
Asking about, do we have a plan in general for separate Git repositories for different parts of Copperhead? And I think the answer is we have sort of one, in the sense that we've sort of, at the moment, everything that is the core essence of a Copperhead build right now is in one repository, and then there's been some various add-on tools that folks have been offering to contribute, like a PowerShell integration for Viper, and some other things that are sort of peripheral to an add-on to Copperhead, and in those cases, We created a separate repository in the case of the PowerShell window. I don't think it's been populated with anything yet. So we sort of have an evolving strategy of, okay, what should be in the core repository and what shouldn't. I think because southbound drivers are supposed to be separated from Copperhead in the sense of their only dependency on it is in a well-defined set of SDK APIs, it probably makes sense for them to build separately and then be integrated. But I think, Evgeny, we were having a kind of a water cooler conversation after the OSU folks did their presentation talking about, well, yes, they are dependent on the SDK APIs, but they're also leveraging some other things that are, as far as I know, not technically part of the SDK, right? They're using the REST integration that we had already built for Scale.io. They're using some of the underlying platform services. And so we need to get a better handle on what is the set of APIs that are fair game for these southbound drivers to depend on and which ones aren't, because along with that, we've got to make a statement on API compatibility release to release. If we're going to promise API stability, we have to know which APIs we're promising it for and not the entire Copperhead tree.
I know this, and this is my concern, because if they use some libraries, REST libraries, which were built for, like, as part of the other things in Copperhead, this introduced dependency. I prefer that they maybe you copy these libraries and use them independently. It's their proprietary REST kind of client libraries, because I don't. It will be hard to standardize on these things.
There may be a set of tools that we want to provide that are not technically, I mean, maybe we decide they're part of the SDK or whatever it is we provide, but there's some place for some shared tools, but we need to know very well what they are and rule some libraries in and some out, or else we could break any given driver by changing any API and not realize it. So that's you probably need to know.
Yes,
So there is a Copperhead, and there is the driver code, and then there is the storage backend. Three different pieces. So what I have seen in the past is driver code. Sometimes it gets embedded into the base package. Sometimes it is separate, depending on what software you're talking about. So, for example, the Docker guys have most of the drivers outside. When you put in the volume driver, it explicitly states that it depends on this software, this runtime already up and running before you actually start managing it. So they don't bundle the storage backend APIs, anything. They explicitly state the dependencies and let someone figure it out. So because bundling that is good and bad. If you have such a tight dependency, you are better off just bundling, because if you have so much of variation in the REST API on the network side, it's extremely difficult to keep and figure out exactly what it is. And if it is not that obvious on what REST API driver it is on the Scale.io instance, you're probably better off taking the Scale.io driver, Southbound SDK driver, and bundle the REST API runtime as well in it, and then package it together. But the packaging is still part of the driver as opposed to really the Copperhead.
My thinking is that some of the drivers, we should have a mechanism so that drivers can be built separately.
Yeah.
We also need to have a mechanism so that from release to release, some of those drivers are pulled into the master branch so that they are shipped as part of your default package. And so, there will be drivers which will graduate from being external to being internal, provided they meet certain criteria. And once they are internal, they by default are then maintained with every release.
So the criteria could be the CI, past certain CI criteria.
Yes, but we are not stopping people from developing drivers which are outside. So for instance, somebody takes Copperhead and he has a way to develop drivers, goes to the UI, brings them in, does all the testing. Let's say 6 months down the line, he thinks, now it's ready to be submitted. Submit to the Copperhead community. Community will evaluate it, look at the code quality, look at all the test results, and then say, fine, you're in. And then you can be in the master.
Yeah, the problem with that approach is this is where we got burnt in the other open source projects. It is a function of having insight into the storage backend. And I think that the community has that insight and they can look at the code quality. You can just run through the standard assertions and say this code looks good and all that stuff. Doesn't mean that it is functionally sound and it is something that really makes sense.
Right, the person looking at code doesn't understand the storage system. Exactly. They don't know if it
has been a pretty much dominant feedback. Because even in the developers have insight into the storage backend, so that you have that expertise to say this is a sound driver versus this is not a sound driver, even though it works functionally.
You need a performance tool or something?
Yeah, there was a question about conformance testing, and it just adds more and more scope.
It's too much work.
So they tend to stay away from that. If NetApp guys are going to write a driver, you expect them to figure out that the driver is robust enough for it to be with a certain quality. They can use the CI framework just to make sure everything works together, but it is their ownership to make sure that the driver is sound and it is something that really works and scales and all that stuff. Because there are a lot of other challenges, like failure recovery. Who's going to do it? I mean, you have a new NetApp driver, NetApp backend for you to really validate it. You don't have it. So I feel uncomfortable saying that.
But why would you worry about validating NetApp driver?
Yeah, exactly. So the moment you get into the situation where certain drivers will go in, you start creating a criteria on what goes in and what is outside. And so if the criteria is extremely loose, anything that is ready to go and passes the CI, then it's a different thing. You know, if you start actually creating a criteria that is a little bit more on the quality side, it gets to conform to the quality. Because you need to have a CI lab with a specific storage backend for you to really say this quality driver. So the difference between functionally ready versus quality driver, you really need to be very good on defining the criteria to be in of the core or out of the core.
So when we say we want them to do CI, we just want functional. You know, you created it through no exception. The rest of it is their responsibility. Like an SDK level test. That's how OpenStack does it.
But Reddy's got a good point. That doesn't mean it's going to work well in a high volume situation.
But is it our responsibility to secure work in high volume situation?
I don't want us to be I don't want the community to be responsible. I want the driver owner to be responsible of all those things. Just because it is part of the Copper, if we do decide that it's part of the CoprHD distro, we have to set a clear expectation. It doesn't mean that it scales. It has, it works for a customer scenario and all that. There natural distributors be there and set a quality expectation to get in beyond just functionally ready by just passing the standards.
I think being part of the distro is more a matter of convenience in the sense that you don't want everyone to go through that process to install the driver through the UI every time. Once we
it's
know
a painful process.
Right. It's a painful process. So we presumably want only the developers to go through that process to validate their driver. That's it. But once it is validated, it should be part of the distro.
I mean, the Linux kernel guys do somewhat similar to that.
But we need to make a distinction.
Right? If you want your driver, your device drivers to be inbox driver distributed with Windows release, you need to pass weekly tests.
Yeah. So there is a quality assurance step in the fleet. I'm saying we can't do that in open. Yes, the CoprHD community open source. Who's going to do that quality assurance, right?
So I think the way you need to handle this is by having a distinction. It can be in the CoprHD distribution, but there needs to be a way to distinguish drivers in saying that this driver is fully supported, meaning the CoprHD community takes bugs on it, or this driver, which is included in CoprHD, is supported by this other organization that submitted.
Yeah, there has to be a
could be. Yeah,
there has to be a tiered system.
As long as we can make that very clear, it has to be fairly transparent.
It has to be.
There are many ways to make that clear. I mean, you have to have, you want it easy enough and frictionless enough so that people will actually submit drivers, but you don't want to make it
process so onerous that they don't want to actually do anything. But at the same time, you don't want, if we release something as part of CoprHD, it can't break so easily. So there has to be like 2 levels of certification. Certification is a bad word. If they're your product managers, hold your ears because they don't like it when the developers use that term. But there's a first cut of here it meets these basic level functionality, and it can be put into a repo, not necessarily the repo. And then once it matures to a certain level, we can have some level of either some level of testing, some level of CI, passes more advanced tests, and then we say, okay, now it's part of our general software collection release. And
so I will challenge that one.
So
let's say I have a Fujitsu Eternal Sapphires.
Fujitsu what?
Fujitsu Eternal Sapphires, right? Very, and I wrote a driver, and I'm going to submit that.
Okay.
All your CI will fail because there is no appliance actually behind the scenes to be able to test it.
Right.
So how do you decide whether it should be part of the CoprHD distro or should it be outside? I take the Hitachi, driver. How do you know that it is really working or not?
Right.
I'm not going to give you the simulator. Even simulator I cannot trust. Then just fails. So that's a challenge we are out.
It is a challenge. I mean,
assume that
ideally, those
empty.
vendors would give us the stuff so we could actually
exactly.
verify.
So that's where we run into all these challenges. Storage, that is the biggest problem.
Side, it is on the vendors. For my driver to be part of OpenStack, I need to have a CI system that gets figured off of check-ins to the main repo that runs against my actual hardware and reports back whether it's successful or not.
I was about to ask you, how do you guys
Yeah,
do it?
we've had these exact conversations too, and there's supported and community supported and things like that. For me, that I've always pushed back on is whether you say it's CoprHD supported or not, for an end user that loads up CoprHD for the first time and tries to describe it, whether it's CoprHD or not, it's CoprHD, and if it doesn't work, it's a bad experience with CoprHD, it's not a bad experience with vendor X, Y, Z. Might as well.
No, that's a good point. Usability is important.
Yeah.
And then there's some implicit certification that I included you.
Yeah, if you get included in the main distro, then the expectation is that you must have done some due diligence, right? You must have tested this, you included and you uploaded it.
Yeah, the question is, do you blindly trust? Do you actively test? And do you actively test with your own equipment? Or do you actively test with the actual driver developer equipment, and you have the infrastructure in place to go beyond the firewalls and make that happen?
Right. So, and different projects will have different commitments to that. So we host some joint test infrastructure here. And yeah, part of that is we have a whole bunch of cell phones hooked up to a bunch of Jenkins nodes, and they never had.
I mean, it's basically like if you look at the Microsoft. If you look at the Microsoft Visual Testing or VMware certification, it's all about either doing with the real equipment with the VMware person on board and checking off saying that it meets the quality, right? Even the SNIA, SMIS compatibility thing, all that stuff in the devices, it's all about checking off and owning that. Really careful.
Right.
In our case, at least for the short term, it's going to be a very significant.
But in that case, I mean, what I would suggest is be very careful about what you bundle in your actual distro.
Exactly.
Yeah. Because if I install CoprHD works, I got to go to Fujitsu to download the driver.
Exactly.
It's clear to me that Fujitsu owns them.
Yeah. What if? I think the default is you keep it separate to start. I mean, then you have to come up with this criteria.
Exactly.
Then we can pull it in.
Yeah.
Once we have the infrastructure and the whole way of.
And that can be kind of a carrot we dangle for them to participate, right? Like, oh, we'd love to include your driver, but
Well, it could be as simple as the vendor has to give one piece of the equipment to pull it.
Whom do you give it to?
It goes to Shane's lab.
Maybe Shane.
I'm in favor of that. He's not here to defend himself, so we'll say yes.
Let's say yes. Yeah, this room's pretty big. We could just start stacking. Yeah. So I think
Those are the things, nagging things that need to be addressed.
Yeah.
Minimum
viable functionality. That should be one set of checks.
There has to be like a unit test
The
level.
second one is
There has to be all these things.
the testing against the actual drive.
Yeah.
Third one is they have to submit something so the CI works even beyond the vendor, like simulator. Right?
Yeah, I mean, it could be, what I'm saying is there has to be a very transparent way of inboxing the drivers versus being outside. Either it is completely loose where anything that is just ready, where you really can't afford to test. You don't know whether the function is really even functionally ready. But it is part because someone made a pull request, someone reviewed and it's good, put it in. Okay, it's part of, it doesn't mean it is even functionally working. Because you can't test with real equipment. We don't have that in our code.
Right, so could we have a driver repository somewhere?
Yes.
And a driver browser, essentially, inside, so you say, I want
You make an app store.
I mean, no, just, so essentially when you're ready to go, you go into CoprHD, go on a page, and then that basically makes a call somewhere, and then once that happens, you can download whichever drivers you want.
Exactly.
At that point, you're
That's my
downloading
point.
specifically, and it's all done from inside.
Yeah. So, but the decision is actually by the end customer.
Right.
As opposed to you forced into bundling with CoprHD based package, thinking about all kinds of innovative ideas to say, hey, this is really in, but may not be working. Oh, this is in, but I certified to my arts content.
Well, we
so
can
rather than actually going into that level of
with that approach, you can still have certified and non-certified available, latest work in progress, whatever.
Exactly.
And as long as there's some place, as long as there's a group of things bundled under a category that says, this is broken, use it at your own risk. I mean, that's
something like that. Yeah.
We have to be clear, like which parts we make those.
Linux call experimental.
Yes. I'm sorry, you had a question? What?
No. I'm trying to say that it might not be a good idea to get the vendor's hardware and that because then you have to keep it there, power it, heat it, cook it.
Oh, I don't want to do that. I want them to use their hardware on site to test. Yeah.
On their own site.
Yeah, exactly. Because they should be doing that anyway, right? I mean,
So,
they can do just upload it.
They do that automatically as part of the build process? Yeah. That seems really cool.
Every patch that gets submitted, you can subscribe to that event stream. So kickoff, new patch coming in, pull that down, load it up, run against it, and make sure that that didn't break anything, even if it wasn't related to your code in any way. Make sure it didn't change some behavior that the person's doing it doesn't even notice.
So is it done pretty much routinely? I know I heard HP does that because it's while CI setup and maintenance is an extremely it takes time and energy from resources and resources needed. So are all companies doing it or only selected ones?
It is a requirement now, and in the last release we actually removed several drivers because they weren't able to get a state. So if you show them that their driver was working right,
it's not part of it.
It's not part of the distribution.
That makes perfect sense.
And they're still non-voting, right, in the Jenkins, so it doesn't.
Right. It just has to comment saying yes, we ran and worked, or ran and something failed. And you get false failures.
But people can see, like, if this driver failed 5 times in a row, then there might be something wrong with that driver now from that one patch.
So the ones that got removed, either they weren't running at all, or you could look back in the last weeks. Last 2 months, it's actually running against anything.
Okay. And basically, somebody's job, in each one of those companies, somebody's job is to set up an app, get this thing running, keep it running.
The good thing about that is, like, you don't get companies coming in and just doing a dump and run on a driver, right? To say that they're supported, right? I support OpenStack, here's my driver, and then they just disappear, right?
Yeah.
They have skin in the game, they have to support next.
So for the single driver for Viper, we set up the CI system. So, I mean, I know how it works. Basically, any code change in the master, you test it on your driver. Essentially, you are not testing your driver, you are only testing that particular code change. Sometimes people introduce code changes which break your driver. So the idea of that thing is to test that scenario. It's not really testing your driver really, but it's testing every new patch to make sure that patch doesn't break your driver.
Yeah, and it's one of those things we want to do also. Haven't been able to yet.
Yeah, I don't think we are at that level of influence where we can
get
answer
that.
Okay, so this is your last slide, Evgeny?
Yes, that's the last slide.
Okay, so I think we talked about this few times, right? I don't know. Ingesting the existing drivers is also an extremely important activity. Here is the reason why, right?
What do you mean by ingesting the existing driver?
Yeah, I will explain. So I think for the past 5 or 6 months, we have been talking to a few storage vendors. And the point is, the discussion goes like this. Hey, I already wrote the Cinder driver. Why should I write a CoprHD driver? So the motivation for the storage vendors to write something native in CoprHD, something that uses Southbound SDK at this point for the next X amount of time is going to be low. So we can't be sitting in a situation where, hey, the Southbound SDK only works with Scale IO and maybe Ceph because one of us wrote it and then the buck stops there, right? Ideally, what we would like to do is figure out a mechanism to ingest the existing Cinder drivers, Manila drivers on the file, vVol drivers on the VMware side, SMIS drivers on the Microsoft side. We'll be in a lot better situation in terms of making traction with the real customer pool. So what happens is you go to the storage vendors, they're not going to write the drivers. You're not going to, it's not going to be that easy for us to go convince them. It's going to be severely challenging to write the native drivers to start with. And if you go to the end customers and say you want to use CoprHD, the first thing they would say is, hey, I have the VMware environment, I have Microsoft environment, I have maybe OpenStack. Your value prop is that I can manage storage resources and service these 3 orchestration stacks. We can't do that because there are no drivers. So it's like a chicken and egg problem. We really need to go figure out what is the best way to ingest, even if it is a scale down, cut down functionality, we have to figure out a mechanism to ingest 100+ drivers out there in Cinder, maybe somewhere around 10 drivers in one.
Do we have that already?
Lots of SMIS drivers.
How is that different from
Cinder Southbound? We already have a solution, right? We can use Cinder as a Southbound solution. That solution we do have.
Yeah.
So before we did that, we evaluated this idea of taking the Cinder driver as it is, right? I mean, that was the original idea. Cinder drivers are written in Python, right? We have Python as part of CoprHD. Why can't we simply use that driver?
Right.
The problem is that every driver includes some libraries, right? Different drivers, like the same problem which Eugenie was saying, that they include some libraries they found in Oslo, or they found something in Cinder, they found something in Nova. They happily include it because they don't want to do it, because it's there in OpenStack, right? That library includes some other library, and that library includes some other library. So essentially, if you have to run a Cinder driver, you end up including all those Python packages. Essentially, it doesn't work.
Yeah. So that's not a technical challenge. Yeah. But you have to look at it from the perspective of what does it take for us to make progress with CoprHD in the industry. So, one side we are sitting there and say, vendors are not coming and writing drivers, and they're not standing in line to write the drivers and go through the certification process. The other side, customers are saying, unless it works with the existing stacks that I already invested in, what can I do with CoprHD, right? We have to figure out a mechanism to enable it. I know there is technically a challenging task, but unless there are hard showstoppers that we really cannot do it, then we are at a dead-end situation. So we'll have to wait for all these storage vendors to come on board, and we'll have to wait for several years or several months, whatever it is, right?
I'm still not getting it though. Don't we already have Cinder driver?
We do have a solution for Cinder. We don't have a solution for Manila or B-Wall or what are the other thing you said. You can't ingest all of those drivers.
We'll have to go look at what it takes to do it, rather than saying we cannot.
No, I mean, I'm not saying we cannot. Today we don't have that ability.
Exactly. So if we agree that ingesting the existing storage drivers is directionally the right step to do, then we can go figure out what does it take to do it and what would be the challenges, what would be the the gaps and all that stuff. For me, I'm struggling because in the developer meetup first time, I was all completely on board with this, right? Then you go and talk to the storage vendors, and we had numerous discussions. You go and talk to the end customers. They are like, okay, I wrote the driver. Don't make me go through this certification process. I'm not going to do that. For them, it is a chore as opposed to really because if you were to look at most of the storage vendors that are going to write the drivers, their future, their focus is going to be OpenStack, and that's what they're betting on, right? If they have to support something in VMware, they're betting on VMware. They're betting on Microsoft. There is enough certification that happens among those three big focus areas. And we are here as the fourth one, and we are trying to say, hey, you need to go through the certification on this one. Either we have a compelling reason and justification to make them actually, they see the value and they jump on board and do it, then it's fine. I'm not seeing that today. So
I think Southbound, there has to be multiple solutions. Native driver is one of them.
Native driver should exist. I'm not saying we should not, but we also have to look at how do we support the existing
other drivers.
And just a question around that. I mean, you would be happy as long as you had a driver, even if it wasn't optimal, right? So even if you lose performance, if it's not a native driver, you have to emulate, you have to translate, you have to do whatever. You were talking about bringing in a ton of libraries.
Yeah, so instead of bringing in libraries, what we did was let's use Cinder through the Cinder API, right? And then you have Cinder drivers. So that way, indirectly, we are using all the Cinder drivers.
Yeah.
So today, if you have a Cinder driver for any array, let's say Fujitsu, right? Fujitsu is a very good example because we actually tested with Fujitsu. We don't have a Fujitsu driver. For some customer, he wanted to use CoprHD and he wanted to use Fujitsu. He was very fixed on both. We said, fine, you have Cinder driver for Fujitsu, use it. And that actually worked. So that way, any array which as long as it has Cinder driver can be used. So, I mean, that's the solution. That's a possibility. That's not ideal because, a lot of the functionality like discovery and all that is not supported. Well, it's a non-optimal solution in the sense that a lot of the stuff that, for example, Eugene is implementing in terms of discovery and all that is not there in the Cinder drivers.
But you could also argue that it's not needed too.
Yeah,
right?
so yeah.
The flip
So
side
we
is
can
that,
say
hey,
it's not needed.
I haven't.
But it gets you in the door, right?
Yeah, it gets you in the door.
Exactly.
You can create volumes, you can delete, you can do all the basic.
The critical 80% of the operations are
available.
True. You go do whatever you need to do, all the setup. I don't care. It's whether automated discovery or manual setup. If people are happy with the manual setup in OpenStack, you force them to change their behavior overnight.
Absolutely.
And then you say, hey, create a volume. I can create a volume. You don't need to write a driver for me to create a volume. By the way, you can't get discovery. Tough luck. You can write the native driver. Yeah. But you put your foot in the door, and then you actually convince them to write. If there is enough compelling value prop, they will write it. And so over the course of time, there may be.
And if you keep track of how many people are using these suboptimal drivers and can report back to Fujitsu and say, look, you've got 10,000 installations of this and suboptimal, your users would be a lot happier if you wrote a native driver, then they got some data points.
Exactly.
So my question's about what? Did the customer deploy that solution?
No, they did not.
And why not?
That was for other reasons.
There you go.
Yeah. Not because of lack of discovery capability.
No, there are issues, there are challenges in terms of how easily you can deploy that kind of a solution.
Are you asking about the Cinder runtime and driver combination, or are you talking about something else?
I'm asking if viably customers will actually deploy those solutions and feel they are supported? That's what I'm asking.
Because you have the issue of, okay, so that driver is written by Fujitsu, right? And Fujitsu will support that driver as long as you're using it in OpenStack environment. Well, you are using that driver in a different environment and they may not be willing to.
It's the customer that decides at that point. It's not Fujitsu, it's not us, it's not CoprHD community. Because if customer A comes on board and says, I want to use it, go get your act together. CoprHD, only CoprHD will ingest a single driver and be able to manage your app plans. Get your act together. You have a choice either to support it or you write it to the core. True. Both options are on the table. You decide. But there is a customer pool that you are creating, and a demand is what you are creating.
But think of a developer. If this thing doesn't work, they say, okay, so forget. Unless the developer has, somebody at the top saying, yes, we need to, or somebody.
That's why the customer has the pull in that situation.
So the customer, so you still have to influence somebody there. So go ahead and do that. Or if the developer at that point saying, okay, I'm not. That makes sense.
The developer won't do anything until he's told by his marketing team who gets the customer out from a phone call, right?
Yeah, so when CoprHD has reached that position where people say yes, so how
then
do
it's
you
a different thing. Yeah. The question is, how do you reach a tipping point before you can start?
Okay, to rein
Making that as a norm.
To rein this in a little bit, I put driver ingestion on our parking lot.
Yeah.
And so probably we should take a break and then get ready for the next
Okay.
session, which I think is supposed to start in about 15 minutes. Is that right?
Yeah.
And we have people off-site that are participating, so we want to.
Take that one
Is that the Docker one or
Yeah, we can do the Docker one, and I know you want.
4:30?
Yes.
You're dialing at 4:30?
Yes.
So we have time then.
Yeah.
I thought you had a set one. Not today.
Yeah.
Is there a set discussion?
It was open storage, I think.
Well, thank you, Evgeny.
Open source.
Yeah.
Thank you, Evgeny.
Thank you. Thank you.
Okay, this brings a close to the streaming for now, and we'll pick it up again tomorrow at 9 a.m. Pacific.
We're not streaming the last presentation.